In this video, I will be covering the technical implementation of Grab and Grab for the mobile games development module. So I'm going to be covering all of the features implemented as part of the technical requirement checklist, and then we'll sort of go from there. So to start off, let's load into the game and just show things off. The first thing that's necessary is a suitable menu system, structure, and transitions. I'm also going to cover appropriate UI that is functional for use on mobile devices. So here we've got the main menu, we've got some very big buttons that are very relatively quite easy to tap, certainly from testing. We've got the buttons up here with the settings one, so you can change the volume by just muting or unmuting sound effects, music, or haptics. The gameplay itself has a full game loop, so you can continue a game, you can just keep working within it, you can go to higher levels, and you can get a game over, at which point you can watch an advert to revive, and then that brings you here. So, in general, I think the UI is quite suitable, the buttons are relatively big, you can use them, there's progression. I'm quite happy with the game in terms of how it's gone with that. I think the UI is fairly appropriate, and I think that the monetization strategy is quite good. So I've also got banner ads here. For some reason they display very small on the simulator. So this shows up down here, and you can see it shows up here in the main menu as well. And then, of course, on top of that, we've got these adverts here, which mean that you can watch an advert and be rewarded for it. So that's the general monetization strategy, since I was unable to implement in-app purchases, but this is the ad delivery service that I've been using. When testing on hardware, it tends to maintain a frame rate of about 30 frames per second, which is good. Ideally, it would be a little bit better. I was targeting about 28 frames per second, just because that means that it has a little bit of time to just cool off effectively so that it's doing less processing. But I'm quite happy with it, to be honest. I'm quite happy with how things have come out. I think it's a relatively good little mobile game for what it is. I'll talk about design patterns and programming practices in a moment, so we've got the different progression mechanics as I've discussed. It's not capable of gathering analytical data, but it does save game data. So if I just finish all of these rows here, and then, oh no, I've been interrupted by a phone call. If I jump back in, it should reload it, and it saves it to the local system. At the moment, it uses a JSON utility, that library, which is provided by Unity, and that means that the data is being stored in a very human-readable format, which isn't so good for cheating prevention, which is generally quite important for this sort of application, especially where microtransactions are involved. But the way that I've set up the saving system should mean that it could be expanded for cloud to support cloud data if the need arises, at which point that tends to be a little bit less crucial. I didn't manage to get retention mechanics in, unfortunately. Originally, I would have had a daily mechanic here, but I didn't have time for it. I've shown off the configurable settings. The UI itself kind of scales. It doesn't have any specific logic for it, but if I go back into the simulator here, you can see that nothing overlaps. It all displays relatively fine. There's a couple small inconsistencies here and there, but otherwise it is relatively just... It looks the same, it feels the same, and nothing overlaps with anything like the cameras. There's no data-driven features, unfortunately. I have included a content management interface, which I developed in an attempt to figure out how to save and load, but I do feel that this could be reused for different, different asset retrieval processes. So here we've got the content loader interface, and as part of this you can then use a resource loader which pulls from the resources folder. But although Unity doesn't recommend this because the resources folder is quite slow, it increases the build, it just includes everything within that folder. Whereas the better solution would be to use the asset bundles or addressable system, since that is a lot more extensible. It can get to a lot of different sources without needing to worry about things. which is why I'm not using the resource loader. I'm instead using a quote-unquote database loader. So this is effectively just a dictionary where the key is just the file name string, and it will fetch a scriptable object or just any Unity type with a specific file type, just based on the string, which I think works fine. It means that you can load and save scriptable objects, for instance, which isn't usually supported by the JSON utility because it will just save the instance ID, and as soon as the game updates or maybe a different play session occurs, then it just loses a reference to that scriptable object and you just lose everything. So I didn't want to mess with that, I just stuck with this. Um, so, yep, they're not quite data-driven features, but we do have support for possible feature support for loading this kind of thing. In terms of native plugins, the game does support haptics. This also uses a haptics service in here. So at the moment, all this does is it takes in this iHaptic handler interface, and that is effectively just a way of tracking how to play the specific haptic library in a sense. So what I'm using here to be, I guess, a little bit more specific is I've got this handheld haptic handler, and all that does is it uses handheld.vibrate, so it plays a single tone just to play the sound effectively. On mobile, this just plays one single tone. Ideally, if it were a proper native plugin, you'd be able to control the different settings, so the duration, the strength, and so on, which would be quite nice. And in future, I may need to update Haptic Handler to handle this. I didn't manage to get social media features in, unfortunately, nor high scores or leaderboards, and I've already discussed cloud persistence. Ecosystem continuity is only supported in as much as the UI scales for it, which is sort of quite hard to really prove, especially with what we've got here. But as you can see, you can sort of, if I press play and then load it up into the simulator again, you'll be able to see that it does stretch to the different screens, as I already mentioned, which means that you can support various different applications, different devices from the same ecosystem as shown here. So in terms of design patterns, primarily I've been making use of the service pattern. I chose this over singletons because I feel like it's a lot easier to track, and having to set up these references is a lot more. It requires you to know exactly what you're doing to some degree. While the function itself, so a button, for instance, that wants to load a scene, it doesn't actually need to know what this scene service is, but it does need to be a scene subject with scene load args as the type of the subject listener. So in here, when a new scene is loaded or when a new UI screen is loaded, what this will do is it will pull a scene initializer for all service subjects of this type, and it will register handle scene change. And the same sort of pattern is used for pretty much every single service within the project, just with different types depending on what library it is and what types it needs to make use of. So in this sense, all a button needs to do, for instance, is raise an event with the required scene load args. Then from there, it will just load the scene. The button doesn't need to know how. This class handles how. So I've tried to, in this way, I'm trying to enforce a mixture of dependency inversion and just keeping functionality separate. The button doesn't need to know how this happens, it just needs to know that it can do it. But even to that degree, I have tried to split up the logic. So if I go into the buttons here, the button itself, I've got a custom one which just takes in the pointer event data, and it's got a list of these button actions. And button actions are what actually call these different events, so you can have multiple button actions on a single button object. And all of these have this handle on click event, so every time a button is clicked, all of these on click events are called, which means, for instance, you can cause a screen to load, you can play a sound, such as a little click sound effect. You can toggle a setting and that interacts with the setting properties, and so on and so forth. So pretty much all of these use that style of programming, I suppose, that sort of pattern, where it's just using these services to access global properties without them being fully global. It forces you to make sure that you know what your system depends on. So I've done this, like I said, pretty much everything. Some of the more interesting ones, it would be saving and loading. So I think I mentioned I've got this saving strategy here, and that determines how the project is saved. And then I've also got this file system interface here, which determines where it is saved, which is how I would, in theory, cloud support support the cloud in future. So in theory, I'd just have a class that overrides this one, and I'd replace that within the saving service, and then it would just work the same way as it does now, just with cloud or in a different format, for instance. Um, so I am quite happy in general with this system. I do feel that there's a lot of duplication still, so some of this could, in theory, perhaps be in its own component, maybe, and there'd be a way to configure it from there. But for what the game is, I'm fairly happy with how things have panned out. I'm quite happy with how I've set things out. I've got these initializers and different functionality to ensure that functions run in the correct order, chain or since the order in which objects have a wait or start called on them differs depending on it just differs. It's not entirely random, but it is random enough that you kind of want to be able to specify exactly what runs first without it necessarily meaning that it always runs first to some degree, which is why I've got these initializers. I've got this debugging library, which just wraps the debug logs so that you can strip that out of the build, for instance, if you don't want that to be within the project, which should speed things up in generally. I've got some other sort of custom collections, and in general, I've tried to keep all of these generic assemblies as to themselves as I can. Whereas all of the game logic is in here, in the CNG folder, in this and libraries. So we've got the game board and the different scriptable objects, including the tile database, which stores all of the tile data, which is just the icon, the value, and so on. And then we've got all of these other game-specific functionality separate from the quote-unquote generic functionality. So ideally, a lot of these systems should be reusable between projects. So I guess to recap, I've been using a lot of the flyweight pattern in terms of scriptable objects, especially with asset wrappers in a sense, where I'm trying to wrap these audio files, for instance, with additional data that can be reused elsewhere. And this makes it a lot easier to just swap out different assets on the fly without having to edit everything. I've been using the service pattern for pretty much every single low level function within the project so that I don't have to keep on duplicating the same logic. In general, I've been trying to make a better use of the component system. I've been using dependency inversion. I've been trying to keep the functionality of each script separate so that they can all sort of tie together without depending on each other. In general, I'm quite happy with the project, and I hope you are as well. So thank you very much for listening. Have a good day.